These are the solutions to 2024's CCEA GCSE Further Mathematics, and it is Unit 3, which is a statistics module, and you're allowed a calculator. Okay, a couple of things in the instructions. Answers are to be given to 2 decimal places, and you've got 6 questions to answer. You'll see you've got a number of formulas given to you for statistical measures, probability, bivariant data, and also your quadratic equation. And then you've got your tables as well, that's for your normal distribution. Okay, question 1 says a midwife records a length to the nearest centimetre of 30 newborn babies. The table below shows a summary of the lengths. So your lengths are its continuous data here. So you've got 45 to 47, 48 to 50, and so on. First thing you need to do here is find the midpoint. So the midpoint x, so you do that by adding the boundaries. So for this one, if we look at this one here, just check the boundaries. It might work by just adding the endpoints and dividing by 2, but sometimes I would check what the actual boundary is. So if you think the lower boundary here would actually be 44.5, and the upper boundary would really be 47.5. And when you do that and divide by 2, you get 46. And that's exactly the same as if you did 45 plus 47 and divided by 2, you'd also get 46. So just check. That technically is the way you need to do it, but it's easier, obviously, to use the other one. So why that's important is if it was maybe written a slightly different way. So if it was like 10 to 20, then it went to 11 to 20, and then it went from 21 to 30, and then 31 to 40, and so on. The boundaries of this are going to be 10.5 and 20.5, 20.5 and 30.5, and so on. So you'd really have to do that. But in this particular case, it was all right. Okay, right. First of all, when you do that, add 45 and 47 divided by 2, you get 46. Next one, doing the same idea, it's going to be 49, 52, 55, 58, and 61. So that's your F column, that's your X column, this column then is your FX. So multiply 3 times the 46, you get 138. I would at this stage do the FX squared column. So that's 3 times the 46 times 46 again. So that gives you 6,348. Then 8 times the 49 gives you 392. Multiply by 49 again gives you 19,208. 10 times the 52 gives you 520, times by 52 again gives you 27,040. 6 times the 55 gives you 330, times by 55 again gives you 18,150. 2 times the 58 gives you 116, times by 58 again gives you 6,728. 1 times 61 gives you 61. Multiply by 61 again gives you 3,721. That's the hard part of the question done. For the rest of this question, we're going to need sigma f. So if you add those all up, you get 30. You'll also need sigma fx. If you add those all up, you will get 1,557. And the last thing you'll need is sigma fx squared. If you add those up, you will get 81,195. Part 1 says calculate the estimate of the mean. So for part 1, we need to find our mean, which is sigma fx divided by sigma f, which is, you can just see those there, 1557 over 30, and that worked out to be 51.9. Part 2, on the next page, it asks you to find the estimate for the standard deviation. So your standard deviation, that's what we're looking for part 2, and I'll just do it on this page so we can see it. That's sigma fx squared over sigma f minus your mean squared. That formula is given to you in the front of the paper. So that was sigma fx squared was 81195 over 30, and then minus your mean, which you've just worked out, is 51.9 squared. Square root of all that, which gives you 3.59 to 3 decimal places. Okay, last bit of this question is a wee bit about changing or scaling data. It says it was discovered at a later date that due to a fault in the measuring equipment, all the recorded lengths were 3 centimetres too long. So what should the estimated values be for the mean? So our mean was 51.9. If you take away 3 from every value, you will also take away 3 from the mean. So it becomes 48.9. The standard deviation. Now standard deviation is just a measure of spread. So if you imagine, here we have a scale. And that's how spread out my data is. If I shift them down by 3, they have the same amount of spread. So my standard deviation stays the same. And my standard deviation I just worked out, let me just check that. I worked, 3.59. It was the 2 decimal places. Okay, fair bit of work to do in this one. This is our bivariant data question. Bivariant analysis question, I should say. It says the marks obtained by 10 students in their written and practical music tests are shown in the table below. So you've got a whole pile of results for the written test, whole pile of results for a practical test, and then what we've got to do is rank them. It says write down in the table above the rank order for the written and practical tests. So how I would do this, I'm going to put the best one as number 1. So the highest value I can find in the first one is this one, it's 1. The next one then is a 45, so that's my second. Then my third is a 44. Then my fourth is a 43. My fifth then is a 42. My sixth then is the 40. And then my seventh is 38. My eighth is a 37. My ninth is a 36th. And my 10th is a 33. Now, there's no problems with those. I'll just write those down in below. So copy in below from what I have above. And you'll see in the next example why I have done it that way. Now, for the next one, I'll do these in red so we can see a slight difference here. My biggest one I have in is my 45. The next biggest then is 43. The next biggest then is 42. Okay, so that was my third place. And then you've got 2 41s. So they're my fourth, both joint fourth place. So it's fourth. So really one of them is fourth and fifth. So then the next value, which was 40, it's actually the 6th place person. And then my 39 is the 7th place person, if I can speak. And then the 38, it's 8th place person. And then 9th, then wherever we are. And our last one is the 35. Okay, right. We need, before we go on, let's just work out. So really those 2 4s represent 4th place and 5th place. Let's average them. 4 plus 5 divided by 2, you get 4.5. So this is how you deal with tied ranks. So I'm going to, instead of 4 and 4, I'm writing those as 4.5 and 4.5. And then copy the other ones down below. Okay, so 2 marks for that, hopefully. That's what we've got that right. Calculate Spearman's coefficient of rank correlation. I'll just write down the formula here. R is equal to 1 minus 6 times sigma d squared all over n upon n squared minus 1. So in this question, there are 10 things. My n is 10. We need to find sigma d squared. So we'll find d, and what d is, it's a difference between them. So 5 minus 1 is 4, 8 minus 8 is 0, 3 minus 4.5 is minus 1.5, 6 minus 3 is 3, 10 minus 10 is 0, 4 minus 7 is minus 3, 2 minus 4.5 is minus 2.5, 7 minus 9 is minus 2, 1 minus 2 is minus 1, 9 minus 6 is 3, and then d squared, so all of those get squared, you'll give you 16, 0, 2.25, 9, 0, 9, 6.25, 4, 1, and 9. So if you total those up, and hopefully I've done that correctly, I got 56.5 when I added this highlighted row up. That's what I got, 56.5. So my R then is equal to 1 minus 6 times 56.5 all over 10 times 10 squared, which would be 100, minus 1 is 99. And that means R works out to be 0.657758. Then your R is equal to 0.66 to 2 decimal places. Okay. Interpret your results. So it's 0.66, which shows it's a positive correlation, not a fantastic positive correlation. I would use the word moderate. So it's a moderate positive correlation. And that's between the written test, your written test mark, and practical test mark. Okay. Next thing it says is calculate the mean mark for the written test and the mean mark for the practical test. So the mean for the written, you just take all those values and you add them all up. So 42, 37, 44, plus 40, plus 33, plus 43, plus 45, plus 38, plus 47, plus 36, and we divide them by the number of them. There were 10, remember, and that got me 40.5. And then the mean for the practical then, same idea, it's 45 plus 38 plus 41 plus 42 plus 35 plus 39 plus 41 plus 36 plus 43 plus 40, all divided by 10, and that got me bang on 40. So there we are. So the mean mark for the written was 40.5 and for the practical was 40. So very, very close. Happy days. Okay, right, bear with me here. And this next one, it says, the data from the table are plotted on the graph below. And it says, and draw your line of best fit. So the first thing, remember we've got our mean mark was 40.5 and 40. So 40.5 and 40 is going to be, 40.5 would be here and 40 would be here. That's my mean mark. Now, why they asked you to do that is your line of best fit has to go through that. So I am just going to cheat a wee bit and put on, I know what my line of best fit I've drawn here is. It went through that point and also my mean point. I'll talk more in a second why I've used that particular point. So that's what we've got. But just let's have a look. I've got 1, 2, 3, 4, 5 values above and 1, 2, 3, 4, 5 values below. So it looks pretty good. Is it perfect? I do not know. So my answer could be really quite different from the answer in the mark scheme. But doesn't mean I'm necessarily losing any marks. It's gone through, my line of best fit has gone through my mean point, 40.5 and 40. And also it's got the same number of values above and below. Now, here you could have drawn this differently. You could have drawn this really quite differently. I could have done, for example, like this, and get a very different looking thing. It still satisfies what they've said, goes through the mean point, and also the same number of values above and below. So you've loads of an infinite different number of answers you can get. So they will really have to work through your working out to do it. Okay, next part it asks you is to find the line of best fit. I'm going to use a nice point. Okay, so a nice point I've got, well, this point I know that was 40.5 and 40. I know that exact value. And this point as well was a nice one. It was 35. There's bound to be at least one nice or two nice points that your thing goes through. I would use your average point, which you've actually worked out, and then some other nice point. So determine the equation of a line of best fit. Let me just write down those 2 points, 35, and 40.5 and 40. Okay, and my line of best fit, it's a straight line, so y equals mx plus c. M is your gradient, it is your y difference. So no, that's wrong. It's my y difference, which is my y values are 40 and 35, and then my corresponding x values are 40.5 and 35. When I fired that into my calculator, the exact value it gave me was 10 over 11. So my equation is y is equal to 10 over 11x plus c. To find the c, I'm going to sub in the 40.5 and 40. So my y value is 40, so that's 10 over 11 times 40.5 plus c, which means 40 minus 10 over 11 times 40.5 equals c. So c to 2 decimal places, I got 3.18 to 2dp's. You check that, please. And then also 10 over 11 to 2dp's would be 0.91 to 2dp's. So my answer is y is equal to 0.91x plus 3.18 to 2dp's. Hopefully that's what they're looking for. It's not going to be what they're looking for. I don't know why I'm saying that. It's going to be a wee bit off because it's a line of best fit from a scatter graph. It's not going to be perfect, that's for sure. Okay. Next question says, there are 5 red scarves, 3 white scarves and 4 green scarves in a box. So that's a total of 5 plus 3 is 8 plus 12. That's a total of 12. Jane selects 2 scarves at random without replacement. By completing the tree diagram otherwise, answer the following questions. Okay, so you've got 5 red out of 12. You had 3 white over 12 and you had 4 green out of 12. Now let's zoom in on this first branch. She pulls out a red, then she pulls out another, so there's now only 4 reds left out of a total of 11. And then the next one then, she's still got 3 whites left out of 11. And then she's got 4 greens left out of 11. So that's the first branch done. The next one. And then you've got 4. Oops, sorry, that's wrong. You've got still your 5 reds out of 11. You've pulled out a white, so you've 1 left red, 1 less red, so 2 out of 11. You've the same amount of green, so 4 out of 11. And then here, you've pulled out 1 green, you have 1 less green, so 3 out of 11. Then 3 out of 11, and then 5 out of 11. And that's you. Okay, so there's your tree diagram. That's what we'll be coming back to for this. This question says, if the first scarf which Jane selected is white, what is the probability the second scarf is red? So just for this then, we're looking for this thing here, this probability. So Jane, if the first scarf she selects is white, what is the probability? So white is this branch, and then we want to get a red after that. So it's 5 out of 11 is your answer there for that one. Okay, next one. It says calculate the probability that the 2 scarves which Jane selects are the same colour. So probability the same is the same as in. So this is just a wee bit of working out. It's red and red, or I can't remember what the colours were. White and white, I think it was, and then green and green. If you set it out well, it really helps you here. So red and red, just to show you here, is this first branch. So 5 over 12 times 4 over 11. White and white is this middle branch, 2 over 12 times 2 over 11. And 4 over 12 times 3 over 11. So that's what we've got. 5 over 12 times 4 over 11, or 3 over 12 times 2 over 11, plus 4 over 12 times 3 over 11, which means 20 over 132 plus 6 over 132 plus 12 over 132, which works out to be, is that right, 38 over 132, which cancels down to be 19 over 66. I haven't worked that out, the TDPs. I would imagine they should be happy with that, the 2DPs, but should be happy with that as a fraction. It's a nicer answer. I would just say that is equal to then 0.29 to 2DPs, but I would imagine that's really what they're wanting you to have. So set out the gap, still get marks. Okay, next bit says probably different colours. Okay, different colours, not even going back to my tree diagram. Different colours is every option except the same. And sure, you've just worked that out. So that's going to be 1 minus 19 over 66, which is 47 over 66. Let's just do that again just to be 100% sure of getting the marks, which works out to be 0.71 to 2 decimal places. Okay, next page was a blank page. We're going with that for some reason. Right, part 3 says, given that both scarves which Jane selects are the same colour, what is the probability that they're both green? So we're looking for green, given that they're both the same. So let's write that down. That means the probability that they're green and, green and the same. So this is from your conditional probability formula divided by the probability that they're the same. Now, being green and the same, there's only one way that can happen, is if you have got green and green, and then probability the same. So these things we have worked out. So if we go back, let's look at the green and then probably the same. So go back to way up here, and this is why setting it out well helps you. So you can see green and green, this was our working out for it, was 12 over 32. And then overall, the probability of the same worked out to be 19 over, or not, in fact, we'll not do it that way, we'll do it another way. We'll leave it as 38 over 132. So 12 over 132 and 38 over 132. So we'll remember that, okay, hopefully. Let's see where we are. So green and green was 12 over 132 over 38 over 132. And if you file that into your calculator, well, it's the same as just 12 over 38, which cancels down to be 6 over 19. And again, I haven't done that to 2DPs. Probably that's what they want. Let's just be sure, 6 over 19. And that is 0.32 to 2 decimal places. Okay. Oh, binomial. Lovely. Okay. Complete. This is the way you do this at GCSE Further Maths. Slightly different than you would do at A-level. You wouldn't really use this at A-level just as much. But complete Pascal's triangle in the grid below. So 1 and 1 adds to be 2. And the outside number is always 1. Then 1 and 2 adds to give you 3. 2 and 1 adds to give you 3. And that's 1. Hence, write down the expansion of P plus Q to the power of 3. So we're looking at this row. So my first thing is P cubed, and it's 1 times P cubed. Next thing it's P squared times Q, and it's 3 times that. So that comes from this. That comes from the 1. The next thing would be P times Q squared, and it's 3 times it. And then that's Q cubed, and that's it. Okay, so this tells us all our different probability outcomes. It says Jason is spinning a spinner with 3 sections marked 0, 20 and 50 as shown. The probability of Jason scoring 20 with a single spin is 0.6. So Jason spins the spinner 3 times and the scores are noted. It says find the probability he scores 20 with exactly one of his 3 spins. Okay, we're told probability of him scoring at 20 is 0.6. So that's our probability of success. So P equals success n is 0.6 and the n is 3, so we've got 3 spins. You may not have seen this, but this means x is distributed binomial n and p. Okay, so that just means x is distributed, it's binomial distribution, n is your number of trials, and we've got 3 trials, and p is your probability of success. So in our case, it's x is distributed binomial, 3 and 0.6. That's your probability of success. We could also add in then, if it's your probability of success, your probability of failure, which is q, is 0.4. It says here he scored, find the probability he scored 20 with exactly 1. So you're looking for probability x equals 1, which we know from our thing we did earlier on is 1 success means p to the power of 1, and 2 failures then is q to the power of 2. So that's 3 times 0.6 times 0.4 squared, which is 0.288 to 2 decimal places then, 0.29 to 2 dp's. I really hope they wouldn't take a mark off you if you don't do that, because it works out as exactly 0.28 to 3 dp's. So hopefully, but just to be sure, just write in, as long as you've got that answer, 0.288, 0.288, and then 0.29, you're definitely going to get the marks. Okay, he scored 20. He scores a score of 20 at least with at least 2 of his 3 attempts. So probability at least 2 is what we want. That means I could get 2, or if you say or you add, I could get 3. So that's going to be 3 to the power 3p squared q plus then just p to the power of 3. Let's just fire those in. That's going to be 3 times 0.6 squared times 0.4 plus 0.6 cubed. And you fire that in and you'll get 0.6 0.48, and again, if they need it, 0.65 to 2 decimal places. Okay, so they change the question slightly. It says, probability of Jason scoring 50 with a single spin is 0.3. What is the probability of Jason scoring a total of 150 with 3 spins? Now, for him to get a score of 150, it's very easy. There's only one way of doing it. That means he would need to get a 50, a 50, and a 50. So that means that's going to be probability-wise, I need to get a 50, which is 0.3, another 50, which is 0.3, and another 50. So when you say and, you multiply. So when you do that, 3 times 3 times 3 would be 27, and there's 3 digits after the decimal place. There we go, and that's going to be our answer. Oh, here. So the 2 decimal places, would they really want us to do this? The 2 decimal places, 0.03 to 2 dp's. I think that's what they're going to be looking for, really. Okay, question 5 says, the masses of a large number of apples were measured in grams. The masses are normally distributed with a mean of 200 grams and a standard deviation of 30. So let's just write down our mu is 200. Standard deviation is 30. So you could say X is distributed, normal distribution, mean 200, and then sigma is 30. Well, sigma squared, that's just the way it's set out. You write X is distributed, normal distribution, mean mu, sigma squared. So that's, I don't know if they're looking for that, to be honest. I'm just putting it in just in case. And what are we looking for? Find the probability that an apple chosen at random has less than, so X is less than 245. So give your answer to 4 decimal places. Happy days. Okay, so I would draw a wee diagram for this. There's my normal distribution. There was my mean. I'm not going to write in what it was, but that's what we're looking for. So less than 245. 245 is there. It's on the right-hand side because my mean here, this thing, would have been 200. So it's going to be on the right-hand side of that, just to keep me right. So I know my answer should be bigger than 0.5. So then Z equals X minus mu over sigma. We've got to use this formula to convert my real life X value into standardized normal Z values. So my X was 245, my mu was 200, my mean, my standard deviation, the sigma, was 30. So that's going to be 45 divided by 30. Oh, yes, 45 divided by 30 is 1.5. So what we really want is a probability that Z is less than 1.5. And if you do that from your tables, how do we do that from our tables? Right, I'm going to go all the way back to start. Bear with me here. So here's my tables. And I wanted to have X is less than 1.5. So you go to 1.5, and it's 1.5, and there's no extra decimal points. So it's this one. So 0.9332. Right, let's get back to the end here, wherever we were. Okay, and there we are. It was 0.9332, and again, just so we remember, that was from our tables, and that was the answer. 4 dp's, lovely. Okay, next question says, find the probability that an apple chosen at random has a mass greater than. So X is greater than 125. That's what we're looking for. I would draw a diagram. There's my mean. It was 200. So 125 would be here. We want greater than, so we want this. Let's do our conversion formula. Z equals X minus mu over sigma. So Z is equal to 125 minus 200 divided by 30. And that gives me Z is equal to minus 2.5. So I really want probably Z is greater than minus 2.5. So I want this, which I can't do using my tables. So we'll do the old switcheroo, switch that around then. Because of the symmetrical nature of the tables, this area is exactly the same. So that means the probability that Z is less than 2.5, that's what we're looking for. And we can do that from our tables. So you go to the 2.5 the tables. I don't want to scoot all the way back to that, but that's what it's going to be. Here, I will just scoot back to it very quickly. So there was 2.5, and the 0 decimal points, so 0.9938, and I think that's what I had written down there. Where are we? Here we go. 0.9938. Okay. Right, on to our last question. Venn diagram questions. Very, very easy to make a mistake on these questions, so just take care. So, it says, in a new housing development, 120 houses are built. Right, that's important. 120 things in total. Houses may have up to 3 added extras, selected from a garage, a sunroom, and a utility room. And it says, of the houses in development, 19 have a garage. 19 have a garage, a sunroom, and a utility room. Okay, we'll write that in first. That's all 3. So that's important. That's this wee bit here. And then it says 26 have a garage and a sunroom. So garage and a sunroom is, 29 have a garage and a sunroom. So that means this number has to be 10, because the 10 and the 19 together have to add to give you 29. 26 have a garage and a utility room. So garage and utility room then is going to be this bit as well. So this has to add to 20, those 2 bits have to add to 26. So 7 and the 19 add to 26. 36 have a utility room and a sunroom. So this number plus 19 has to be 36. So it's going to be 17. So we're down to here. 50 have a garage. So this number, this number, this number, and this number add to be 50. So take those other 3 away from 50, gives me 14. Next thing, where are we? 52 have a sunroom. So this number plus the 10 plus the 19 plus 17 add to give 52. I've done 52 minus the 10, the 19, and the 17. That give me 6. Last thing, 64 have a utility room. So this number, 17, 19, and 7 add to give you 64. So do 64 minus 7, minus 19, minus 21, minus 17, sorry, and that gave me 21. So there it's filled in. The other thing, which I have forgotten to do then, is work out anyone who doesn't ask for any extras. So there were 120 in total. 120 minus and take away 14, take away 10, take away 6, take away 7, take away 19, take away 17, take away 21. So there were 26 people outside. I'd forgotten to put that on mine. I would have lost a wee mark there. 26 people outside. Okay, what is the probability the house chosen? The house selected at random has exactly 2 of the added extras. So let's just do this. This is part 2. Let's do it up here, just so you can see it. So this was me just having exactly 2 then, added extras. So exactly 2 would be this one. So 7 people here, 10 people here, and 17. They have exactly 2. So that's 10 plus 7 plus 17 out of my total of 120. That is the same as 34 over 120, or 17 over 60. Again, you could give that to 2DPs. Let's see, 17 divided by 60 is, so it's 0.28 to 2DPs. Because it's probability, I really think they're going to want this as their answer. Okay, part 3, the last part of this exam, says, what is probably that a house is selected at random. A house selected at random does not have a utility room. What is the probability that this house has a sunroom? Okay, so it does not have a utility room. See if we can get rid of these highlights here. So does not have a utility room. What is the probability it has a sunroom? So we want a sunroom given it has no utility room. So let's just look at the people who don't have a utility room, and I can see I've made a mistake in this. So no utility room would be this 26, which I had forgotten about if I'm looking at my answer here. It would also be these 14, these 10, and these 6. So they're all that's the total people who don't have a utility room. So we're zooming in on those. you'd have 14 plus 10 plus 6 plus those 26. And then what is the probability that it has a sunroom? So the sunroom people are those 10 and those 6. So that's just going to be 10 plus 6. So that is 16 over, and I don't know what this bottom line is because I'd forgotten the 26. 14 plus 10 plus 6 plus 26. So it's that over 56. So 16 divided by 56, that cancels down to be 2 over 7. Again, I would imagine that's what they want. But if you find that as a decimal, it's 0.29 to 2 decimal places. So there you have, that's your last answer. That's what we had to do for your last question. All right, all done.